Welcome to solverfy.
Wow, so I just did 33 and it was so much more involved than 35. So I am welcoming the slight mental break. So basically, you're given the same physical situation as in 29 and asked a bunch of questions about it. You're moving this rail at a constant velocity. And here are some things that are true about the situation. So the length is 0.1 meters and the velocity is 5.0 meters per second. And the magnetic field is 1.2 Tesla. And A asks you to find the EMF. Well, it's just the product of all these. And when I put that into a calculator, I got 0.6 volts. And for B, they ask if it goes up into or out of the page. So if you're moving the rail to the left, you're increasing the flux, assuming that your flux is originally positive, which you can call it without loss of generality. So you're increasing the flux. The loop wants to decrease the flux to oppose that change. So it wants to create a magnetic field into the page. So it drives a current clockwise, which means it's going up on the rail by one of the right-hand rules. And as for the current, that's just EMF divided by R. And that is 1.5 amps. And it asks if it's going clockwise or counterclockwise. And so it's going clockwise if it's going up the rail. And E asks the power. I'll use I squared R. So plugging in 1.5 amp, and then for I, and then R, I forgot to write that down. R is equal to 0.4 ohms. So plugging those two in, I get that it's 0.9 watts. And then for F, that's the force, and you can just use the formula. In the book, everything they did to derive this formula applies here as well. So plugging all that into a calculator. Oops, move the decimal place. 0.18 newtons. G. Oh, it is a G. Okay. You want the work, it's force times velocity. So 0.18 times 5. Like slightly distracted by my confusion over why this is the last problem in the section. It seems identical to the first one, but I would need to reread them. Okay, so yeah, multiplying by the velocity 5, and then I get 0.9 watts.